We'll proceed in pseudo calculus problems. Okay, beginning shows the morning shows the day. Means when we have started pseudo calculus problems, we would tackle many problems that are extremely tedious into the mathematics. I'm not saying extremely tedious into calculus because we don't know if we really need to use calculus. Okay, we start our problem with the normal mathematics and then we proceed in a manner that we feel that we need algebra, then we feel that we need calculus, then we feel that we need vector. Okay, this way we proceed. I was seeing this Bayesian theorem in artificial intelligence. People are using Bayesian theorem and everywhere in neural science to text processing, NLP, natural language processing, to everything Bayesian theorem is being used. And there, earlier it was summation. Now, summation, normal summation is replaced by integration because summation or repeated summation is multiplication, and multiplication, when it comes in the form of algebra, then it becomes integral calculus. So everywhere multiplication or repeated addition is being transformed into integral calculus, division are being transformed into differentiation, where there is a game of algebra and there is a game of dependent and independent components. Mind blowing, amazing. What we need to find here is in multiplication, there should be only two components, not three or four. And division also, certainly, there will be two components. And in that fashion, people try to change it anyway. Now we are in phase of calculating the surface area of a circle. Surface area of a circle. Anyway, we have found surface area of a circle through innumerous ways. I don't remember actually how many ways we tried finding that. Primarily in three ways we tried finding the surface area of a circle. One is height into width is the area, that I know. Height into width is area. If height is y and width is x, y into x is the area. Height, height of a 2D shape. If I have a two-dimensional shape, I have a width and I have a height. Every point on the width, if I take width as a line, and every point on the width, I have height. If height is constant everywhere, this means that height is not dependent upon the width. Both are independent to each other. Then the area is y into x. But there can be a scenario where height is variable at different point in the x. And then we say height is dependent upon x because at every different x, height is different. Like height equal to cos x, where x is in radian. If x is 0, then height is 1. If x is pi by 2, height is 0. If x is minus pi by 2, height is 0. Otherwise, in between. Means height varies as we note the x value. If I know x value, I can estimate the height. If I know the x value, I can estimate the height. Y into x is the area. If I say there is a cosine wave, can you calculate the area of the cosine wave? Area means if this is x-axis and this at 0 radian, cos is 1, and then at pi, it becomes 0. What is the area between pi by 2? I'm sorry, pi by 2 and 0, whatever the cos is making one line. With that line and with x-axis, there is the area underneath it. What is the area? Okay, that area is height, that is cos x, into x, that is the width. This is the first approach we used. Now, if height, that is cos x, is dependent upon x and x is independent variable, this will be transformed into multiplication, will transform into integral calculus, and that will be cos x into x rather than cos x into dx. Cos x into dx. Now, if I just say x, then x is 0 to pi by 2, means the gap is pi by 2. If I say dx, then that gap I have to mention as a limit 0 to pi by 2. That's it. Okay, this is the first way set. Okay, whatever the function over x for the circle is y equal to square root of a square minus x square. It becomes x is from minus a to a, square root of a square minus x square dx. And that would, if this is x axis and this is the circle arc, first half, top half only it will give area, multiply by 2, full circle. Then we found that height into width is the area. Height, that is y, into width is the area. What is height? Okay, if I take if I take a normal rectangle, then this is origin, this is the height. Consider this point is x2, y2. This is origin and this is the width point x1, y1. x1, y1, origin x2, y2. In that sense, this is now what is the area? x1 whole square plus y1 whole square root into x2 whole square plus y2 whole square root. These two gives the area of a simplest rectangle if I take if I take 2D shape. Now x1 whole square plus y1 whole square root is same as x1I plus y1j vector magnitude, that is x1 whole square plus y1 whole square. So if I say if this is vector A and this is vector B, then A vector, that is x1I plus y1j magnitude into B vector magnitude. That is also an area. Another way of looking into it. A vector magnitude into B vector magnitude, provided this angle is 90 degree. If it is a parallelogram, then A vector cross B vector is the area vector. Okay, then magnitude of area vector will give the area. Then there was no limit when we proceeded into this fundamental. A cross B, two sides of any 2D shape, A cross B is the area vector. Calculating the magnitude of area vector gives the area. Then we saw many ways, not one way, many ways in Cartesian coordinate system, in pure Cartesian coordinate system, in pure polar coordinate system, Cartesian polar hybrid model that also we saw. Cartesian polar hybrid model in 3 dimensions that also we saw, and polar in 3D that also we saw. What is remaining? We will see spherical coordinate system. First we will see hybrid model, then we will see pure spherical coordinate system. Okay, calculating the surface area of a circle in pure spherical coordinate system. Can someone believe it? In pure spherical coordinate system, we can calculate the surface area of a circle. Okay, what is pure spherical coordinate system? That is under question mark. So pure spherical coordinate system, if I talk, what approach I am going to take in pure spherical coordinate system? What approach I am going to take in pure spherical coordinate system? If I take r theta plane in pure spherical coordinate system, there is a polar plane that is called r theta plane. And r theta plane, there is a circle of radius r. Then there is another angle called phi. I believe people are aware of the spherical coordinate system. So spherical coordinate system, it has three components. One component is angle on xy plane, or I won't say r theta plane, I said r theta plane, because r in a spherical coordinate system is all along. R is in xy plane also, r is in yz plane also, r is in xz plane also. Everywhere r is there, not confined to the r theta plane. This is theta plane. Okay, this is vertical plane is called phi plane, r phi plane, and horizontal plane is called r theta plane. If I take any point P here, If I take any point P here, then it will have coordinate as R, vertical, vertical arc and horizontal arc. This P is R, comma, R phi. With vertical, it makes phi angle. R phi, comma, R sine phi theta. I'm sorry. If I take horizontal arc, I'm not taking theta and phi is the point. If there is any point P here, then what is the point P here? Length is R, radius, this is origin. This is origin. This is length R, that is radius. Radius, comma, theta, comma, phi, wrong. Because theta, comma, phi are angle where radius is length. If I talk about length in theta, comma, phi, then theta, if I talk length, then theta in xy plane will make an arc. That is the length, that is r theta. Okay, if I take this as r and this is phi, then it becomes r sine phi theta. If this is the r and this is phi, then it will be r phi. That is the arc in vertical plane. So any point P on the surface of a sphere is r comma r sine phi theta comma r phi. Okay, if that is the case, then what is the, if this is the case, if this is the case, then what is the surface area? If this is the case, then what we can consider in the name of surface area? So we are not calculating the surface area of a sphere. We are calculating the surface area of xy plane, that is r theta plane. That we are looking for the surface area, not the full surface area. So more or less it will come as polar coordinate only. But mind it, r is not this. That is the catch here. Okay, R is not this. Okay, if when R is not this, R is anywhere here. R sine phi comes in theta r plane, and R sine phi theta is the arc. So there is the catch. Anyway, okay. So we will try. Probably we will try. I have not tried with the hybrid model. I have not tried with the hybrid model. Let's try with the pure spherical coordinate system. If I take pure spherical coordinate system, then what would be the surface area? If I take pure spherical coordinate system, pure spherical coordinate system, if I take any point P here, any point P on the surface of a sphere P, then P is R, R, R into R unit vector. I'm sorry. P is R comma R sine phi theta comma R phi, where phi and theta are angle. R phi makes arc in vertical plane. R sine phi theta make arc in horizontal plane. And in that fashion, R is the radius. If I from center, if I draw a position vector to point P from center, if I draw position vector point P, okay, if that is the case, if I draw position vector, then what will be position vector? Then it will be R unit vector, R R unit vector, comma R unit vector, R sine phi theta unit vector, plus, I'm sorry, not comma, R unit vector plus R sine phi theta unit vector, plus R phi unit vector. That will be the position vector at any point P on the surface of a sphere. Okay, what is variable here when I'm trying to calculate surface area on the xy plane? R is variable and theta is variable. Phi is not variable because phi 90-degree constant I have taken. If this is the angle, phi angle from the vertical, when phi is 90-degree, then full it will fall in xy plane. Anyway, now what is the area vector at any point P? Area vector at any point P, if I take area vector at any point P, then I have to take out theta and I have to take out r from the position vector. Then there will be two length vector where theta is variable and r is variable, and cross product of these two means I'm trying to do cross product of two position vector. One is r unit vector plus r r unit vector plus r sine phi theta, theta unit vector plus r phi, phi unit vector. Cross product be the same thing, r unit vector plus r sine phi theta, theta unit vector plus r phi, phi unit vector. If that is the case, then here this one side I'll take out theta, making at theta as variable component, because theta would vary in the surface area of the this, and r would vary. And this side we will take out r, making phi as constant. If that is the case, then it will become, if I take out theta, then theta outside and in bracket it will become r by theta, r unit vector, plus r sine phi theta by theta gone, theta unit vector, plus r phi, r phi by theta, phi unit vector. Cross product with r I have to take out. If I take out r, then it becomes r unit vector, r by r 1, r unit vector plus r sine phi theta by r theta unit vector. Okay, theta unit vector plus 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 r phi by r, phi by r, phi unit vector. Anyway, now I'll put division and differentiation and multiplication and integral calculus. Then first will become r unit, I'm sorry, dr by d theta, r unit vector, dr by d theta, r unit vector, plus another will become r sine phi theta unit vector, plus r d phi by d theta, phi unit vector, bracket close, d theta cross product with r, r unit vector plus r sine phi d theta by dr, theta unit vector, plus r d phi by dr, phi unit vector, bracket close, dr. Okay, will this give the area vector? Certainly not. It will not give the area vector, because we have taken d theta dr as independent component. I'm sorry, we are trying to find area into theta r plane, and in that fashion there will be only one independent component. Two are here, d theta d phi. I'm sorry, d theta dr. In that way, we have to find area through calculation of the volume. Then only theta r plane will become independent to the vertical. So vertical. So in this arena, in the vertical, when I'm saying, then r and theta we have taken as one coordinate, I mean two coordinate, they are variable, and phi I have taken as vertical to them. Anyone imagine whatever he can imagine. Now in that fashion, I have to multiply with the r phi, phi unit vector. I'm sorry. I have to, I'm sorry. Then I have to multiply with the vertical component. Okay, to find the actual volume. Anyway, if that is the case, let's settle down first the area vector. That is dr by d theta. Now, if I talk about the volume and phi as vertical component and theta r as the horizontal component, then vertical is dependent upon theta, means phi is dependent upon theta r. This is how we are taking in 3D. Means theta and r are independent to each other in this fashion, and phi is dependent upon them. I mean, this is the way we are taking it into the consideration. Okay, when we are taking it into the consideration in that fashion, dr by d theta will be 0. Now it will become r sine phi theta unit vector. That's it. R sine phi theta unit vector. D phi by d theta will be 0, because theta and phi, they are orthogonal to each other. Okay, how much it is, the explanation is satisfiable, that we will see. Anyway, it becomes r sine phi theta unit vector. D theta cross product with, I have to settle down the next one. There we have r unit vector plus r sine phi d theta by dr. It is again 0. R d phi by d theta again 0. It will become more or less r sine phi theta unit vector cross product with r unit vector. it will become r sine phi unit vector. R sine phi unit vector. Okay, I'm sorry, r sine phi unit vector. That will become area vector for the theta r plane, not on the surface area I'm talking, just theta r plane. R sine phi unit vector d theta dr, where d theta dr, theta is 0 to 2 pi and r is 0 to a. Makes sense? Now we have to multiply this area vector with the height vector. If I take the real height, then it is r cos phi, r cos phi unit vector, r cos phi unit vector. Okay, we will settle down this in more detail, but right now how it is. R cos phi unit vector dot product with R sin phi unit vector. If that is the case, phi will be 1, R cos phi. If I take vertical in a spherical coordinate system, if I take vertical, then phi is 0. Okay, and R theta plane I had taken, then phi is completely 90 degree. R sin phi, or just leave it. Sin phi and cos phi, just leave it. R is R when we have taken vertical, height is 1. That's why we are calculating volume of a sphere where height is 1. Then only it will give the surface area. If I am calculating volume of something where height is 1, then it will give, and volume is surface area into height. Indirectly, we are calculating the surface area only. If that is the case, then it will become more or less r sine phi d theta dr. Theta is 0 to 2 pi, r is 0 to a. R square by 2 pi. Pi r square sine phi is the area of a circle in spherical coordinate system. In spherical coordinate system, where r a square by 2, 0 to a square by 2 pi, a square by 2 into 2 pi, 2 gone, pi a square sine phi. If I take phi into consideration, then phi is the angle from the vertical. If that is the case, if phi is angle from the vertical, if that is the case, then phi we are talking about xy plane. If I am talking about xy plane, phi is permanently 90 degree everywhere. Sine 90 degree is 1, means pi a square is the area of a circle in xy plane in a spherical coordinate system. Mind blowing, amazing. There can be other proof also. Other proof in a way that we will take phi r plane and we will take phi theta plane. Okay, if I take a sphere, if I take a sphere and any point P, then I am free to cut P in phi r plane. If I am free to cut P in phi theta plane. So in phi r plane, if I say phi r plane, then what is the length vector? And if I say phi theta plane, then what is the length vector? What is the length vector in a spherical coordinate system? R unit vector plus r sine phi theta unit vector plus r phi unit vector. If I say this is in phi theta plane, phi, if I say this exists in phi theta plane, if it exists in phi theta plane, then we can take out theta. Same thing we are repeating, but with different explanation. Any point on the sphere, if I take point P and if I cut two lines and take cross product of two lines, that gives area vector at that point. Now in that sense, I have cut it in phi theta plane and phi r plane. Phi theta plane if I take, then the length vector that will come as taking out theta from here. Okay, so or more or less I can say dp by d theta. That will be length vector in phi theta plane. dp by dr will be length vector, line vector in phi r plane. If I do cross product of these two, I'll get the area vector at point P. dp by d theta cross dp by dr. Whatever you do, you'll come to this location only. dp by d theta cross dp by dr. dp by d theta in phi theta plane, r will be constant. In that sense, dr by d theta will be constant. If p is r theta, r unit vector plus r sine phi theta theta unit vector plus r phi unit vector. So in that way, then theta will be dr by d theta will be 0. d phi by d theta will be 0 because height we have taken as 1. In that way, phi is constant. If I take that, we will see later. Okay. So d phi by d theta, we can leave it as it is. But anyway, it will become 0 only tomorrow because we will finally, I'm sorry. Okay, d phi by d theta, considering phi is also constant because we are trying to calculate the surface area in r theta plane. If that is the case, then in r theta plane, whatever r theta plane is exactly xy plane or in some height, phi will always be constant. Means d phi by d theta will be constant. If someone settled on dp by d theta cross dp by dr d theta dr, then he will come to the same concept r sine phi d theta dr. Okay, but no need to proceed further here, and this will magnitude of this, I mean r sine phi unit vector d theta d phi, magnitude of this will be r sine phi d theta dr. Now phi is constant, that is 90 degree if I talk about the xy plane. So the area of this circle in the spherical coordinate system in xy plane will be sin phi r dr d theta. Pi a square sin phi is fixed 90 degree and it is pi a square anyway. Now we started a discussion that I have a, if I talk about polar coordinate system, if I talk about a polar coordinate system is a circle where at the center there is a radius and radius is moving in angle theta. So it starts from 0 and radius is moving 90 degree, then pi degree, then 3 pi by 2 degree, and then 360 degree. This is the radius. If this is the radius, then this is called polar coordinate system, r and theta. But whatever I am showing, r and theta, this is in xy plane. XY plane it makes radius. But if I take theta r plane, then because r is not dependent upon theta, r is not varying upon theta. If I move angle theta, r is constant. Means r and theta are independent to each other as far as circle is concerned, where it is concentric to the origin, centric to the centered at the origin. I have theta r plane and I have xy plane. In xy plane, theta r plane and xy plane. In xy plane, I have a circle, that is x square plus y square equal to r square in Cartesian coordinate system. In polar coordinate system, circle is in a way that x equal to r cos theta and y equal to r sin theta any moment. If this is the radius and this is angle theta, then x component is r cos theta and y component is r sin theta. If I take theta r plane purely, then it will form a rectangle where theta axis is this and r axis is this. It makes a rectangle in theta r plane. Whereas mapping to theta r plane in xy plane, it forms a circle. Consider it is not independent in r theta plane. R equal to cos theta. This is one example. What is area of the circle? That is under question mark now. What is the area of the circle when r equal to cos theta? If I go to theta r plane, r equal to cos theta will form a cosine wave. They are not independent to each other. In xy plane, what it will form? If I say r and theta are independent to each other, x equal to r cos theta, y equal to r sin theta, then in xy plane this will form a circle where theta and r are independent to each other. If I say r equal to cos theta, in theta r plane itself they are dependent on each other. And then in xy plane, if I say x equal to r cos theta, y equal to r sin theta, then what what shape it will make in the xy plane? I believe question is quite all right. In xy plane, I have x-axis and y-axis. Now I have x equal to r cos theta. This is the relationship of xy plane with the another plane that is called r theta plane. X equal to r cos theta, y equal to r sin theta. If I go in theta r plane, r equal to cos theta, they're again dependent there. If that is the case, then what is the shape it will form in the xy plane? That is a question mark. Okay, what shape it will make? Let's try. In xy plane, let's write x square plus y square. Let's write x square plus y square. X equal to r cos theta, r square cos square theta, plus y equal to r sin theta, r square sin square theta. It will become r square, I'm sorry, it will become r square cos square theta plus r square sin square theta, x square plus y square. Okay, x is r cos theta, x is r cos theta, and y is r sin, y is r sin theta. It will come as r square, where r, I'm sorry, I'll try it again. X equal to r cos theta, r is cos theta, x equal to r cos theta, and r is cos theta means x equal to cos square theta, y equal to cos theta sin theta, in that fashion. Now x square plus y square, what it would be? Then x square is cos to the power 4 theta plus cos square theta sin square theta. I believe that will be x square plus y square. If that is the case, x square plus y square equal to cos to the power 4 theta plus cos square theta sin square theta. That will become cos square theta only. Other will be 1. Cos square theta is x. Now equation is x square plus y square equal to x. That is x square minus x plus y square equal to 0. Equal to 0. That will lead to x minus 1 by 2 whole square plus y square minus 1 by 4 equal to 0. I believe it is alright. X minus half whole square is x square minus x plus 1 by 4. So x minus half whole square plus y square minus 1 by 4 equal to minus 1 by 4 equal to 0. If I proceed, then it will become x minus half whole square plus y square plus 1 by 2 whole square. It is again a circle. Can someone believe it? If r equal to cos theta and x equal to r cos theta, y equal to r sin theta, it forms again is a circle in Cartesian coordinate system. In polar coordinate system, it make a cosine curve. Now the circle equation is x minus 1 by 2 whole square plus y square equal to 1 by 2 whole square. Means this is a shifted circle of radius half. If this is the Cartesian coordinate system and this is the origin, then there is a circle, shifted circle with center as half, and this circle has radius half. This is a circle. This is a circle of radius half, and this is a circle. Circle end is origin. It is if I take a half radius circle at the center, it will be like this. This will be like this. This circle is shifted rightwards, and then circle the left point is touching the origin and centered at half comma 0 and radius half. This is a circle. Anyway, what is the area of a circle r equal to cos theta? What is the area of a circle when r and theta are independent to each other and x equal to r cos theta and y equal to r sin theta? For that we have spent ton of time. What is the area of the circle where r equal to cos theta? Someone has to find it out. Anyway, we will see. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.